Okay, welcome to this brand new video here on, well, a lot of work I suppose, on the double angle formulae. So we're going to prove these things now. So the double angle formulae are when you got sine 2 theta, cos 2 theta and tan 2 theta. Now, the end of A-level trig is quite difficult because you're told to learn the compound angle formulae and then use them, which can be quite confusing for a lot of people. Okay, so what we're going to do is we're going to prove what sine 2 theta is using the addition formula, what cos of 2 theta using the addition formula is, and what tan of 2 theta is using that one. That's the more challenging one. These two are quite simple and you can get them done pretty quickly. So sine of 2 theta then, we've got sine of, well, we can write that as sine of theta plus theta, or theta plus theta, whatever you want to say. And that is sine theta times cos theta plus, because we got a plus there, sine of theta, cos theta, or cos theta, sine theta, whatever you want to say. How many sine theta, cos thetas have we got? We have two of them. So we got 2 sine theta, cos theta, and we're done. Now, part 2 says what's cos of A plus minus B. So we've got cos of theta plus theta. This is the easy one. Because we've got, now because we've got a plus, it'll be a negative in the middle, because it flips into a cos, if we remember rightly. So we get cos theta times cos theta, so cos squared theta, minus, because we have got the plus there now, sine A, sine B. We'll sine of that, so we'll get sine times sine, so we'll get sine squared. Easy. Now there are two more variations. If you know them, you'll know that sine squared plus cos squared, I'll write this down, sine squared x plus cos squared x is identical to 1. So we get cos squared x is 1 minus sine squared x, and then we got sine squared x is 1 minus cos squared x. Those are your Pythagorean identities, which you'll learn in pure year 1. So we've got 1 minus that, so we got 1 minus 2 sine squared theta, and the other one, well, sine squared replacing 1 minus cos squared, so we got 2 cos squared theta minus 1 there, aren't we? And that is that one. Now, the tricky bit is yeah, the more I don't know how to say this. The more challenging this gets, you'll spot as you come along in terms of the course that we have here at A-level. Now, tan of A plus minus B, so we've got tan of theta plus theta. We've got that. Agree? Good. So, we've got tan of this. Now, we've still got the plus minus here, so we can add on another tan theta. And then on the bottom, we've got 1 minus now. So we've got 1 take away tan squared theta. Yeah? Because it's 1 minus plus tan A tan B. Yeah? Good. So, tidy this up. We've got 2 tan theta over 1 minus tan squared theta. Now you might be thinking, what is the point of having so many more trig identities? Well, the point of it is you can replace these in a trig equation, right? So if I had, for example, 2 sine theta cos theta is 1, I can jump to the next line. We'll say that sine 2 theta then is equal to 1, because I know what 2 sine theta cos theta is, that's sine 2 theta. So I can sub that in there, and then using the idea of changing the range, so we would double whatever the range we've got here for this example, because 2 theta, because the range is initially for theta. I'm not doing a range in this problem, but you can see where we're going with this, and you can solve the equation like you would in pure year 1. It's just a little extension of using these addition formulae. The proving for the addition formula, or the compound angle formula, whatever you want to call them, is sort of in the midst a little bit. Like this, what we do now here at A level is we kind of step up this knowledge, right? Because you by now, at this point in the course, you probably know that one. You probably know that one pretty well. That one you might be a bit unsure of because it is kind of one in the dark. So we'll start that one. That is one that you might want to learn. These are good to learn as well, so make sure you know those off by heart as well. And make sure obviously you know your Pythagorean identity off by heart. But we'll get to the point now where we can find angles of sine of 3 theta, cosine of 3 theta. And we will have to use these in order to manipulate them. And that is a common exam question. Write sine theta in terms of 2 theta and theta. Or express sine 3 theta in terms of theta, or in terms of sine theta, I've said in the past, on the old spec. But it can be applied here to the new spec, of course, because it's still on the spec. Alright, so that is how we can prove the double angle formulae from the addition formulae.